Hey y'all, it's Henry, not Henry. So you want to learn about the quadratic formula, but you've got the IQ of the average toilet bowl and the reading comprehension of the above average Redditor. No problem, I got you covered. I happen to be a professional idiot who posts things for fun on the internet, and I'll drill this into your head so well that even you will be able to remember it for the rest of your life. First off, we're going to start with the formula itself. When ax squared plus bx plus c is equal to 0, then x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Damn, boy! Now you might say, oh, but there are so many letters and not enough numbers. I miss when math was just numbers. Numbers are the coward's way out, and I refuse to let you keep your IQ in the negative numbers. So you're going to eat your alphabet soup, and you're going to like it. Now let's walk through each of these letters that you're so scared of. A and B are called coefficients. They are multipliers to whatever they're attached to, kind of like buffs or debuffs in video games.
All of this just works.
A is a coefficient of x squared right here, and B is a coefficient of the regular old x. C is a constant. Now what's a constant, you're asking? Let's fire up all 2 brain cells you got in that skull of yours. A constant is exactly what it sounds like. They are numbers which aren't changeable. We can't replace them all willy-nilly once we're stuck with them, just like how your parents can't replace you once they have you, even if they desperately wanted to. Now the whole point of this formula right here is to find x. What's x? It's our variable. Unlike constants, we can plug any number that we want into where our variables are, kind of like how you can stick anything inside the square hole and it just works out.
Oh my god!
Now that we finally know our ABCs, we've advanced past kindergarten and we can finally get into the meat and potatoes of this whole operation, or as I like to call them, the meat and potatoes. You're thinking, well, that's great and all, but
what the fuck is this?
Not to worry, my sweet summer child, I'm about to break it down so easy it would even give the average neckbeard the confidence to leave his mother's basement. We're going to go over every single aspect of this formula and why it's there, and I'm going to implant it so deep in your brain it's going to be right next to the... First off, let's see what we're actually looking at here. We're going to turn this quadratic equation into a graph and... oh my god, it's beautiful. Just look at it, it's gentle slopes, it's out of this world curve. Oh my god, it goes on forever.
Give your meat a good old rub.
That's right, this enchanting specimen of a graph is known as a parabola. In case that word is too big for you to remember, you can just call it a curve because it's a curve. And mathematicians are very creative.
Yeah, boy.
Now that we're looking at this graph, I can tell you what our letters actually mean. Our A multiplier will affect which direction our curve points and how fast it is growing. If our A is positive, then the parabola is going up. If it's negative, then the parabola is going down. When the A is really big, that means our parabola is going really, really fast. And if it's small, it's going really, really slowly. Just think of this A as the level 100 mob boss who calls all the shots. Remember our good old C constant? Well, let's take a look at why it's really called the constant. Let's mess around with our A and our B a lot. You see how this point right here doesn't change? What else do you notice about this point? That's right, the height of this point is our C. That's because it lies right on the y-axis, where x equals the amount of money I have in my bank account, which is 0. When you go back to our quadratic equation, whenever you plug in the amount of grass that you touch this year, all of our x's go away and all that we're left with is our C. But if we keep our A and our B staying the same, then our C will basically tell us how high our curve is.
That's a surprise tool that can help us later.
And now all we have left is B. What exactly does this thing tell us? If we keep our level 100 mob boss the same, that means it keeps the same direction and same scale. And if we keep our constant the same, that means that the curve is always going to be going through this point. That means that the only thing left that we can change is that when we shift B, we're actually shifting the curve from side to side through the constant. Now we can finally start to break down the quadratic formula.
Whoever threw that paper, your mom's a
Everything that this quadratic equation is, we can point to the graph and say, look, it's just what the graph says, and we'll all live happily ever after. Okay, let's break the sucker down. First, we'll break this fraction into 2 parts. We can do that because the 2 terms are being added/subtracted in the numerator and they share the same denominator. It's kind of like how we can split 1 plus 2 divided by 4 into 1 divided by 4 plus 2 divided by 4. Okay, let's take a look at this first part, negative b divided by 2a. Does it look familiar? It should, because it's actually the formula for the axis of symmetry. What is the axis of symmetry, you ask? Well, let's take a look at this graph. Let's move our curve a bit to the left so we have a better idea of what we're looking at. Now we're going to draw a line straight down the middle of this curve, and notice how this line kind of acts like the mirror that you're too ashamed to face in the morning. On both sides of the line, the graph looks the same. This line right here, this gorgeous line. is the axis of symmetry because that is the axis, or the line, where the graph is symmetrical. You find that this line is based on the formula and will always be splitting the curve in half. Always. Okay, great. Now the next part is going to be the second fraction. We're going to ignore the addition and subtraction part for right now because it might be too advanced for your monkey brain to handle. Now it's going to be looking mighty scary right now because of that square root, am I right? Not to worry, Professor Henery is going to beat the square root so hard that you don't need to wet your bed at night anymore. The stuff inside the square root actually has a special name, the discriminant. Now what comes to mind when I say discriminant? No, I'm not talking about civil rights. I'm talking about organizing our answers so that they're separate, but equal. What the inside of our square root looks like will tell us how many solutions it has. What are solutions? Well, I'm going to have to direct your attention over here to this curve, which I've moved down a little bit. This flat line right here is called our x-axis. The points where our curve crosses over onto the x-axis are called our solutions because they solve everything in your life. If you got to take out the trash, solve. The kid is bullying you, solve. Those are our solutions. What does this have to do with our quadratic formula? Whatever our x comes out to be according to this formula is where our solutions are. If you notice, if we move our curve just a little bit up, our curve doesn't cross the x-axis anymore. That means it has no solutions. No real solutions at least, but that's a topic for a different video. And if we put the bottom of our curve unbalanced on top of the x-axis just as well as the US is balancing on the edge of total economic collapse, we will only have one solution to this curve. Okay, now that we've learned what solution is, we can come back over to the discriminant. Like I said before, the inside of our square root will tell us the types of solutions that we have. In other words, it will discriminate our answer. If the inside of the square root is positive, we'll have 2 real solutions. If the inside of the square root is 0, we'll have 1 real solution. If the inside of the square root is negative, we'll have no real solutions. Simple, right?
Right? Wrong.
Why the hell does it work? Let's go back to our graph over here. Henry Sensei will show you the ways. Let's take a look at a curve that does have real solutions. Since the curve is being cut in half by the y-axis, our y-axis will be our axis of symmetry. What do you notice? That's right, our solutions are the exact same distance apart from the axis of symmetry. It makes sense though, right? Right? If this is our axis of symmetry, then everything is symmetrical, including our distance. So if one of our solutions is this far apart, then the other solution has to be the same length apart. I'm going to bring it back to our formula again. Now I think you've leveled up enough to understand the concept of the addition and subtraction symbol. Basically it means that we can add or subtract. I know, hold your applause. If we're looking for solutions of x, then we need to go some distance away from our axis of symmetry. That's why we start with negative b divided by 2a. And if we go either left or right from the axis, that means we will add or subtract some number. What number? Why, this number, of course. After we add or subtract that number, we're left with 2 different things that x can be. Now I'm going to put some more numbers on the screen. Don't wet your pants, this is just to help us see what's going to happen to the numbers as we change our ABCs. If our discriminant is positive, that means our square root will have some number at the end which we can add or subtract. If our discriminant is 0, that means that we'll be taking the square root of 0, which is of course 0. And that means that our second fraction goes away completely, which means that our axis of symmetry will have nothing to add or subtract, which means that we only have one number or one solution, which is on the axis of symmetry. Now, if our discriminant is negative, that means that we'll have to take the square root of a negative number. And of course, that means that we'll have to... Now, what makes our discriminants positive and negative and 0 and whatnot? Let's take a look at this b squared business first. Well, since b is squared, it's always going to be a positive number because a positive number times a positive number will always be positive, and a negative number times a negative number will always be positive as well. So the further along you go in either direction of the x-axis, the bigger our b squared get. The more positive our discriminant becomes, the more likely it is to have solutions. Why is it more likely? Because when you change b, you're shifting the parabola from side to side, and since the parabola is infinite, if you change b for long enough, then eventually you're going to cross the x-axis no matter if the parabola is pointing up or down. Now let's take a look at this 4ac. Since this part right here is multiplying everything together, if one becomes bigger, the whole thing becomes bigger. If one gets smaller, the whole thing gets smaller. Now for the a part, if it's negative, that will make the negative 4ac term positive because a negative times a negative equals a positive. And remember that if a is negative, that means that the curve is pointing down, and our c will shift our curve up or down. The more positive the c is, it will have 2 effects. It will raise the curve further above the graph, which means that it will eventually cross the x-axis if it hasn't already. Second, our 4ac term will become even bigger as a positive number than your mom. meaning our discriminant will become even bigger and our solutions will become farther apart than u and a social situation. The more negative our c is, the opposite will happen. It will move our curve below the x-axis, taking away any real solutions because our 4ac term has become really negative, which makes the whole discriminant negative. These same arguments can be used for when a is positive as well. Try it out. And finally, we have this 2a on the bottom, looking like it's Joe from u. What's it doing there? Well, since it is on the bottom of the fraction, the bigger a gets, the smaller the whole fraction becomes. So when a gets really big, that means our curve becomes way skinnier because it scales way faster. That means that our solutions, if we have any, will become way closer. And oh, would you look at that? If a becomes bigger on the bottom, our fraction becomes way smaller and our two answers become way closer. Now that's nice and all, but now you're wondering, where the f did we get this formula from? And that's an excellent question. And there we have it, the quadratic formula made so easy that even you can do it. When you want to find the solutions of any quadratic equation, all you have to do is just plug in your alphabet and out comes our answer, as simple as that. If you guys want me to explain where this formula actually comes from, I'm going to need like 2 likes before I even start on the script. Remember to hit that big beautiful red button right about there to join the journey. We're on the road to 1 trillion subscribers. I need every single 5 IQ monkey brain soldier that I can get. Well, that's all for me. Peace.